My name's Andy Kyle and I'm the head of environmental consulting services at EFI Global in the UK. So the conceptual site model is a very basic picture, but it's a thought process essentially. The purpose of conducting the investigation is to come up with this understanding of any site. It's vital that you identify what the source of the contamination is. What are the contamination's physical properties? What are its chemical properties? So we understand the source. We then need to think about the pathway by which that contamination might move. So how does the chemical move? Does it move through the ground? Is it leaching into the ground? Is it getting into streams or into groundwater? Is it in free phase as maybe free product, free fuel sitting on top of groundwater beneath the ground? Is that then dissolving into the wider environment? Have you got a problem over a much bigger area, which can take a very, very long time to remediate? And what are the receptors apart from that? Is there an impact to building structures? Physically, the structure of the building, is the contaminant soaked into the brickwork, into the masonry, or is it under the building, causing vapours inside, which can cause problems for the habitants, the humans with inside the building? So quite a few different things to think about, but without a good conceptual understanding of the site, the remediation scheme is ultimately going to fail. So it's essential that this is done to achieve the remediation goals and get sign-off for the client. So at EFI Global, we could be dealing with a sudden loss of contaminant. It could be a fuel tank spillage, or we can be investigating longer-term contamination, maybe involved with an industrial land use on a brownfield site. In either case, the investigation is going to be similar. We could be collecting samples of air. The picture on the right-hand side here is just a simple photoionization detector which monitors concentrations of volatile organics within the air. We can then establish if those concentrations are high enough to cause a problem to the humans breathing that air. Or we could be collecting physical samples. The picture on the left-hand side is a rotary drilling rig, and this is a rig that can be used to core holes into the ground. I've drilled holes using one of these down to anything up to 150 metres, so very, very deep down into the ground where contamination can still be a problem. And we can use this machine to collect samples of soil in the top, say, 5 metres, and then into hard rock, and then install them in a way that you can collect groundwater samples after the fact. So following the investigation, lab results will be received. And at EFI, we can use our knowledge of environmental forensics to examine these lab results and really establish what type of contaminant we're dealing with. Each different contaminant would have a different chemical fingerprint. And you could be working on a site for a client who's had a sudden identifiable loss, say of fuel, but that could be on a contaminated site already. So it's important to establish between maybe what's insured under that particular incident and what's a historic problem. These are the type of graphs we received back from the laboratory, and detailed analysis can give you, even on a basic scale when you're just looking at hydrocarbons, is it a kerosene fuel, a diesel fuel, or a mineral oil, or a combination of there in between. And this, building up this type of information can lead you to question, is the client liable for any of the cleanup at all, or was it a pre-existing older contamination event? So if you've proven you've got a contamination event, you've got contamination in the ground, you can move into the area of remediation design, and this can get very technical, so I'll just introduce it. There's two main camps, if you like, of remediation techniques. Ex situ techniques, so physically removing the material and treating it and either taking it away or cleaning it and putting it back, or in situ techniques which can avoid the need for removing material from the ground. And it's essential then that a risk assessment is conducted dependent on the key receptor driving the risk, driving the remediation scheme. Following remediation works, it's essential to ensure that validation samples are collected to prove that the site has been remediated to an appropriate level, and that's then signed off by the appropriate governing body.